All right, so today we're doing 8.5. Hopefully we'll get through most of the lecture. Tomorrow, then, will be whatever is left over of the lecture plus work day. Monday, Tuesday next week is review. Wednesday, Thursday, the final test, which is your final day to turn in homework. So make sure if you're behind on homework, you get it all in by Thursday next week. Before we get into 8.5 for our bell work, Jacob, for number one here, I got this right triangle, and I want to find out what this angle is. What do you think we should do first?
I'm honestly not sure.
Okay, I think this is, if I were able to use the practice, this is an ACT question, so it's not really something we learned about this semester, though we did a little bit of it in Unit 6 or Unit 7. I think what we have to do then is use trigonometry to find this, and the first thing that you want to do is label the sides. So which side is opposite our angle theta? 8. Which one is the adjacent? And then which one is our hypotenuse? Yay! Okay, and then it doesn't really matter which pair you use, but you're going to pick a pair and then tell me what sine function relates that pair in order to find out what theta is. So let's say, for example, let's use the one that's not a radical, or the two that aren't radicals, 8 and 3. That's the opposite and the adjacent side. Which of our trig functions relate opposite and adjacent? So you might have them in terms of y and x. If you think like this is how far we go to the right, our x units, as far as we go up or down, or y units, and then this would be like, this one would be like r. So then it's tangent, yeah. So we'll say the tangent of theta is equal to the opposite over the adjacent, 8 over 3. And if you were taking the ACT on Tuesday, a nice phrase to remember, your sine, cosine, and tangents, which are pretty much all you need for the ACT, is so, ka, to, right? And then if you're trying to use the opposite or adjacent, or let's say like you knew the angle, but one of these were missing, right? You just label your sides, identify the pair, and then say which of the trig functions relates to that pair. In this case, we did opposite and adjacent, so that'd be tangent. Okay, you got one more step here to get theta by itself. How do I get rid of this tangent? Not divide. It's the opposite of taking the tangent of something? The inverse, that's right. And I think on the actual ACT, this is how far they went for the, I think it was like question 26 of the 2015 ACT or something. That's how far they went. You didn't even need to type it into your calculator. But if you did go one step further and tell me what the actual degree is, just make sure then that your calculator is in degree mode, or if all the answers are in radian, make sure your calculator is in radian mode. Yay? All right, thanks, Jacob. All right, number 2. Okay, Sonia. We want to prove this. It's going to be a number of steps in order to do that. I'm going to have you help me with the first one. So when I say prove this, basically what we're talking about is I want to take this and use the same skills I would use to simplify it, and hopefully when I'm done simplifying it, it's going to give me that as the answer. That's the goal. When you're doing that, your general strategies are to use your Pythagorean identities, if you can, and then your reciprocal and quotient identities, if you can, to get everything in terms of sine and cosine. But for this one, I think what you would like to do first is deal with this. Whenever you see a trig function squared in your problem, one of the first things you should try is using a Pythagorean identity. So if you check your notes from, I think for you it would have been, oh no, you wouldn't have been here at all. Oh no. Okay, can somebody help out Sonia? What's the trig identity or Pythagorean identity for tangent? Oh, okay.
Is that secant plus 1 plus secant minus squared?
So yeah, I think it's 1 plus tangent squared
Yeah.
equals secant squared, right? That's one of the Pythagorean identities you should have in your notes. Now, the issue with this is it's not quite in the right form right now. We want tangent by itself, and it's got this plus 1 next to it. But Sonia, how would I fix that? Hey, just minus 1. So then this would become tangent squared of theta is equal to secant squared theta minus 1. So the first thing I'm going to do for number 2 is I'm going to try and replace this with that. Okay. Now I say this is the way I'm doing it, but the way there is more than one way to prove this. There's really one way to do almost all of the problems that I give you on the homework and quiz and test. So if you didn't start out doing that and you started out converting it, you still might be okay. You just you know what your goal should be. Your goal should be getting secant theta at the end. So whatever series of steps you do, as long as you're using an identity or a rule each time, you should be fine getting the final answer. Mercedes. These two look suspiciously similar. Yeah, they do. What do you think I could do to this one? Notice that this is a perfect square, and this is a perfect square.
So you could square root it.
Like, okay, kind of square root. We kind of, let's factor it first. The problem is we can't square root it because it's not this whole thing quantity squared, right? It's just the secant is a perfect square and the 1 is a perfect square. So when you have a difference of 2 perfect squares, you can factor it. And if you factor it, you'll get this. Yay?
Yeah.
Do we see why that factors out the way it does? Whenever you have a difference of squares, like for example, if you have a squared minus b squared, the factors of that are always going to be a plus b times a minus b. And you can check your work. If you multiply these back out, a times a is a squared. A times negative b would be negative ab. B times a would be positive ab. So those two would cancel out. And then b times negative b would be negative b squared. Right? Or if you think about trying to factor it, if I'm saying what multiplies together to be secant squared theta, well, that would be secant theta and secant theta. And then what would multiply to be negative 1, but add, if you think the middle term here is 0, be 0, then it would have to be positive 1 and negative 1. Those multiply to be negative 1 and add to be 0, so that you don't have a middle term. That makes sense? Yeah? Okay, now that it looks like this, what do you think we should do next? Maybe. Cancel out. That's exactly right. Those two, the secant theta plus 1 is in the numerator and the denominator. So if we cancel those out, what you'll have left is secant theta minus 1 plus 1. That is division. And then I won't call anybody else new for this, but what do you think the next line is? What happens with the negative 1 plus 1? It just becomes 0. So this just becomes secant theta. Hey, that's what we're trying to get by addition. Oh. Yay? So again, for this one, I kind of wanted to show this example because for this one, you don't have to convert it to sine and cosine at all. Usually that's a good strategy to do, and I say it works like 95% of the times, and it would work for this one. But you can get to your answer, I think, quicker if you don't convert it and you just use your Pythagorean identities, and then you factor this when you notice that the denominator would be one of the factors of the numerator. So this one really relies on your algebra skills in order to get the last answer there. How do we feel about that? Awful? No? Oh, pretty good? That's not the answer I was expecting. This stuff is tough. This is the hardest unit for, we're going to solve more difficult trig equations today, but I think for my trig people last year, this was much harder for them, the hardest unit, than solving the equations. Okay, any questions on the bell work? Are you ready to move on? Mercedes?
Could you just cancel out the beginning instead of doing all that extra?
Cancel out what in the beginning?
Where you wrote Pythagorean identity, right? Yeah, couldn't you just...
Go straight from, you're saying like straight from here to here?
No.
No, that's illegal. You go to jail.
Okay.
No, okay, well, okay, technically, if you know, right, that the factors of this include that, you could go straight from here to here. That's true, right? You know that this is a factor, or you know if you do like long division or that kind of stuff, and just actually go ahead and divide those, that you're going to get that as an answer, that's fine. So, yes, I guess you can go straight there to there. That's true. Yeah? But if you did see that, I would be impressed. For me, I have to factor it first to see that it'll cancel out nicely. I guess, I don't know. I know. If you set it up, right? If you set it up like this. And you say how many times does secant go into secant squared, right? And you say it goes into it secant times, right? And then go ahead and do the long division there. You could go straight there if you knew that that was what was going to happen. Okay, so then let's talk about solving more difficult trig equations. And I'm going to say, I don't know if there's any real new skills that you learn about in this lesson. It's just applying all the skills we know to how to trigonometric equations. Just taking all the skills you know. So for the main thing we're going to say is that if you have a trig function squared, right, like a lot of the problems they give to you that will be, here, let me just show you. Like, for example, the first one they give you will be 2 sine squared of theta minus 1 equals 0 for 0 degrees is less than or equal to theta is less than 360 degrees. So for a problem like this, where you're asked to solve this and find out what theta is equal to, you're going to treat most of these ones with trig squareds with the same skills that you would treat a quadratic equation with. Okay, so just use your skills for solving quadratic equations. And that can include, so that's going to, for these ones, you could probably solve it algebraically and get the quantity squared by itself. If it was a trinomial, right, then you would have to factor or quadratic formula. The only thing is, if you're using the quadratic formula, then it's not going to be x is equal to negative b plus or minus square root of b squared minus 4ac. It's going to be sine or cosine of whatever of x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so the only difference if you want to use quadratics for these ones are the quadratic formula for these trig equations that are in a quadratic form is since your variable or your quantity squared is not just x, but it's this whole function, then you have to put that whole function in front. Okay. So let's try this one. What would be the first thing you would do to get theta by itself here? Yeah, add the 1. So you should get 2 sine squared of theta is equal to 1. Then what would you do next? Yeah, divide by 2. So sine squared of theta is going to equal a half. How do we get rid of the squared? Square root. Okay, I'm going to write something wrong, and then you're going to tell me why it's wrong. Okay, so that's wrong. What's wrong about that? Well, sure. I mean, yeah, that is true. You could split this up, but okay. All right, even if I fix that, you're right. That's another problem that's wrong. Even if I fix that and call this, you know, the square root of 1, which is 1, over the square root of 2, and then you can't have a square root of the denominator, so you move it to the numerator. All right, square root of 1 is 1, square root of 2 is 2. That becomes square root of 2 over 2. All of this is still wrong. All right, maybe I should say it's half right. Half wrong. It's this right here. It's got to be plus or minus on all of those, right? Because if you think about even a simple one like x squared equals 4, if I'm saying what number squared is 4, well, the positive square root of 4 would be the answer, and the negative square root of 4 would be the answer, right? Positive 2 squared is 4, and negative 2 times negative 2 is also positive 4. So you have to put that plus or minus there. That's the one thing that I think when we do the test next week that will catch people off guard. For the more difficult ones is the plus or minus there. So what you get then is really, if you want, you could separate this into two equations. You could say sine of theta is equal to the square root of 2 over 2, and the sine of theta is equal to negative square root of 2 over 2. And then solve both of those separately, if that helps. I don't know if you need to do that. As you get better at these, you probably can skip that and treat it all the same. What would be the next thing I should do, really, for both of these to get theta by itself? How do I get rid of this sign? The inverse. So theta is going to be the inverse sine of the square root of 2 over 2. And it's going to be the inverse sine of negative square root of 2 over 2. And you might be tempted to grab your calculator for that, but you actually don't need to. That's on your unit circle. Square root of 2 over 2. What value, what angle produces square root of 2 over 2? For since this is sine, right, for the y value. Pi over 4. Oh, well, in this case, degrees.
Oh, 45. Well, it's 45.
What? Yeah, 45 degrees. Is square root of 2 over 2?
Yeah.
Yeah. Yeah. Yeah. So our first answer is 45 degrees. What about for this one? Even further.
Just kidding. It's 225.
Even further. Yeah, our negative 40. If you did this in your okay, so remember, arc sine limits the range, right, to negative pi or limits the domain to negative pi over 2 to pi over 2, or from negative 90 degrees to positive 90 degrees. So the actual answer to this is this, but you're right. If you add 360, the real answer in quadrant 4 would be, what did I say, 350 degrees? All right. So I said one thing that you're going to do to get these answers wrong on the test next Friday is you're going to forget the plus or minus. The second thing you're going to do, I think we've done a pretty good job of this in this class, but the second thing that you're going to do is you're going to stop the problem right here and you're going to say, good job, me. I'm so good at trigonometry. My mama and papa would be so proud of me. When really you only have 2 out of 4 of the answers. How do I find the other answers? I'll go back to this. In which other quadrant is sign positive? Yeah, this is the one in quadrant 1, in the second quadrant. And again, if you look at your unit circle, you see that, right? And the second quadrant at, I believe, 135 degrees. It is also square root of 2 over 2. And then the other answer you gave me, too. Yeah, that's exactly right. You could, if you didn't have your unit circle or you didn't remember that, that is the same thing as 180 minus your reference angle, which is, in our case, 45.
Actually, we can just look at the table, right?
Exactly. For this one, you can just look at the table, because all 4 of them are on there. One of them, you already told me, was 225. That's the one in quadrant 3.
Wait, so do we have an answer for each quadrant?
That's, well, for this one, that's right. That's exactly right, because it does the plus and the minus, right? So it's going to cover whenever you get square root of 2 on over 2, which will happen 2 times in the positive, 1 in each quadrant, and 2 times for the negative, 1 in each quadrant. So you end up covering all 4 quadrants for that one. Okay. I don't know. Let's try another quadratic one. Slightly more difficult or slightly different than that one.
Wait, I have a question.
Well, okay.
Which one is the third? Yeah, we have to-
This one. That's it. This is the first answer, second answer. Oh, whoa, 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 whoa. Who wrote that there? Kate? Okay. That's the third answer. Yeah. Second answer, fourth answer. So again, the numbering really doesn't matter there, right? The key is that you have all 4 answers. The values of theta that will make these true are all 4 of those. And actually, before you move on, you might be sitting right now and thinking, wow, I don't know if I could do all of that on my own. Or if I did, I don't know if I'm confident that I'm going to catch all these fine details that Mr. Lake seems to be making up as we do this problem. Right? So here's what you could do. You can okay. I want to determine how best to phrase this. You can find all 4 of these answers using a different method. That's a lot easier. But come on, okay? I need you to know how to do this too. Because if you're going to be in AP Calc next year, solving these kind of equations and being able to do that arithmetic is an important skill for you to know. But you can find or check all of these answers by graphing. And so on the actual test next week, I'll give you points for having the right answers and points for showing the work. If at the end of the day, this you're still struggling with by the time you have to take the test, you could at least give me the answers by graphing, because you could do that. I'm confident everybody in this class could do that. All right, let me show you what that would look like. If you grab your TI-84 and you hit y equals, all you would do is type in general, you'll type in this as y1, you'll type in this as y2. Now, to be honest, you don't have to do it when it's 0. That's an exception. If this was like 5 or something, you would want to do it. But I'll just type in, for mine, 2 sine squared x minus 1 and 0. What? Oh, good question. In the TI-84, this is how you would have to type it in. So sine squared, I would type this in as, here, I can erase this stuff below it. Where'd my eraser go? There it is. You would type it in like this. 2 parentheses sine, it'll open a parentheses, x, close parentheses, actually, you don't really need this for a set of parentheses, squared, like that. The sign of, should, I believe for most of yours, open a set of parentheses for you. You'll type in x, close the parentheses, and then square it. Okay, anywho, if you do that then, and you hit graph, in the top right, you should get something. I will adjust mine to make it look like. Yeah, you'll want to change. Well, okay. If you change it to degrees, then you're going to have to change the x scale to go from 0 to 360. If you leave it in radians, then that's fine. Just leave it in radians and then convert all of your answers to degrees afterwards. But you'll get a graph that looks like this. And you'll see that there are 4 spots where they intersect. And if you use your calc tool, second trace, I believe it's option 5, you can find the intersect between any 2 lines. Or in our case, you could just use the 0 tool because, again, we're finding the zeros. And if you did it correctly, you should get, like for the first one, those. Yay? Beep, bop, boop, beep. So you could get all 4 of the answers using your TI-84 just by graphing and finding the intersection. Or again, for this one, since you're intersecting with the line y equals 0, just finding the zeros. Okay, do we need help? Yeah? So did you change it to degrees or radians?
It's in degrees.
Oh, it's in degrees? You dropped it.
Thank you.
Okay, it's in degrees. Okay, so then the window is actually given to you in the problem where you would say it's 0 to 360, right, wherever you wrote that. So, yeah, change that to 0 to 360, and then it should look
Minimum and
fine.
the maximum?
Min and the max.
For both of them or just?
Just the x's.
Oh.
Yay.
I did it for both of them.
Yeah. So, yeah, you want to change your window. Well, first, Mercedes, check your mode. Mode. Change it to degree, and then change the window to match the constraints it gives you, which is 0 to 360. Hey, that looks good. All right, do we know how to find the intersect?
Second count.
Yay. All right, window? Well, actually, hold on, mode first. Yeah, change it to degree, because that's what it asked us to do. And then it told us that we had to go between 0 to 360. So you'll do 0 to 360. And then hit, you hit second trace. And then option 5, your intersect.
Oh.
There you go. All right, we doing okay over here?
So this
Okay.
is in radians.
That's in radians. So if you do the intersection here, you're going to have to convert your answers to degree. If we change the mode to degree and then change the window to go from 0 to 360,
So this would be
0.
and that traces.
That's right. Then you'll get something that looks like that.
Why doesn't mine go through the 0 like yours does? Mine just stops at the 0.
Oh, that's because you forgot the -1.
Oh.
Wait.
There you go.
So
And then
rest is the same, right?
that looks good. And then if you hit graph, you can find the zeros by hitting second trace,
Oh my god.
or in your case, the second trace, and then option 5.
Oh.
And then it'll you'll ask you to move the cursor to where the intersection is on the first curve,
Oh, that's. Oh my god.
and then you hit enter. And then it'll ask for the second curve, which is the same spot on the second curve. So you hit enter again.
That one.
Nope,
No, that
nope.
one. Wait.
So this is now on the red line instead of the blue line. So you just hit enter again. And then hit enter one more time.
Oh.
And then it tells you the answer is that.
Oh.
Good?
Yeah.
That's really.
Yeah? Yeah, you need to change your oh,
Is that-
you closed the parentheses too late. Right after the X.
Right over the X and then my. Okay.
Okay. Yay? Okay. If the calculator part is messing you up, then okay, good.
The batteries in this are running low.
Okay. Put Ella, put that one on my desk. I'll change the battery afterwards. All right. And really, if you're doing it for like the homework, I would just use Desmos.com because you could just click them. But if you plan on taking the ACT again or the AP Calc test, it is important you know how to use your TI-84. Okay, let's do another example. What are we on? Sub-point 2. Okay, I'm going to put 2 problems up here on the board. Let's see if you can get them. All right, so I'll give you, let's do this one really quick. I'll give you a minute to try x squared minus 3x plus 4 equals 0. I would, if I was doing this. That's probably the fastest way to do it, is to factor it. Yeah, so for me, my next line is this. Now tell me what goes in those spots. Okay, if you hate factoring and you want to use the quadratic formula, that's fine. It's going to take you a little bit longer than you probably need to. Okay, apparently I was just straight lying about being able to get through most of these problems. It's going to be, I think, Friday. I don't know how much time we're really going to get to work.
Wait, it might be a student.
What? You can, oh, hold on. Are you saying, did I? Oh, yeah, you're right. You're right. You're right. There you go. Yeah, that'll make it easier to factor. The other one would, your signs wouldn't work out right. Okay, Jenna. What's the first term in our factors going to be? What has to multiply to be x squared? X and x. All right, so find what goes here. What are my two numbers are going to be? All right, let's check that. Those do multiply to be -4, but they add to be +3. So, perfect. All right, and then if we were going to solve this and actually tell me what x is, these need to multiply to be 0. So, what are my two solutions here that make these 0? Yay! Okay. For this one, do you notice the similarity? Right? I could do this is the exact same problem, except instead of x, I put cosine theta. So we can still factor this as cosine of theta minus 4 times cosine of theta plus 1 equals 0. Right? It's the same quadratic form. Cosine times cosine is cosine squared. Cosine times 1 is plus 1. Cosines, -4 cosine of theta is what you would get for multiplying the middles. -4 cosine of theta plus 1 cosine of theta is -3 cosine of theta. And then -4 times 1 is -4. And now you'd have to solve these. And then this one you probably just can't do in your head. You'd have to actually work it out. We want cosine of theta minus 4 to equal 0, which means the cosine of theta would equal 4, which means theta would be the arc cosine of 4, or the inverse cosine of 4, which is what? You look at your unit circle. Where do you have an x value of 4? You don't. The highest x value you could get is 1 to -1, right? That's the maximum on your range for cosine. Cosine of theta can only equal between -1 and 1. This is outside the range, which means for the inverse, it's outside of its domain. So this is no real answer. Yeah, huh? Okay, how you would really do this is try typing it into your calculator right now, the cosine inverse of 4. It doesn't matter to me whether or not you do ratings. It says error. You cannot remember, you can only take the cosine inverse of numbers between -1 and 1. Because if you remember your graph, it is limited as the highest is 1 and -1. Right? Okay, for this one though we could do, that would be cosine of theta plus 1 equals 0, which means the cosine of theta equals -1, which means theta is the arc cosine of -1. And again, this is another one you can get an exact answer. Where is arc cosine, or where is cosine of an angle? Give you the x value? 180 degrees. But again, that'd just be one answer. They didn't give us a limit on what theta could be. So the full answer for this problem is theta could be 180 degrees plus 360 degrees times n, where n is any integer. Right? If I add 360, I'll be at the same spot in the unit circle where I get an x value of -1. Or if I subtract 360, I'll be at the same spot. And I could do that as many times as I want, and you always will end up at that same spot where the cosine of that angle will give you the answer, -1. All right, how do we feel about this? Okay? Following along right now?
Wait, I didn't understand like cosine of the article for
Yeah?
like I know that like from the calculator.
Exactly. So our question is, the cosine of what angle gives us a ratio?
There's nothing.
Exactly.
It's just like -1.
Because remember, cosine is x over r, right?
Yeah.
Under this, x would be 4 and r would be 1. The leg of a right triangle can't be longer than the hypotenuse. It's impossible.
So it's not. There's no answer if it's not 0, -1.
If it's not between -1 and 1, no answer. All right. The homework is not due till Monday, and we'll finish this lecture tomorrow.